Hello all, hope you all doing good. This is Mani and I'm back with another stream. Let me know if you can hear me and let me know if the audio or video or anything is not fine, and we will start in a minute. Okay, you can connect with me on the chat. Just ping or just post in the comments if the audio, video, or my voice is not clear, and we will I'll try to um, get that right within the time. Okay, that said, we are already 5 minutes into this. Now we'll get started. Mm, Hope it's fine now. Hmm. Yeah. Um, okay, I think there was an issue with my audio. I'll start from the beginning. So we haven't done very much, like a lot. So yeah, this should be fine. We will start, understanding about data architectures, and what goes into like building data pipelines and managing the data infrastructure for data engineering projects from a business perspective, right? So the first thing here is that as a fresher or as a beginner into data engineering projects or data engineering um, field, when we enter any projects, right? They the project manager or a lead would assign us to monitoring jobs and check for any failures. So that would be like the ideal way to introduce a beginner to understand about what's really going on in day-to-day activities, right? So they will start monitoring all the activities that are happening in the any scheduling tool like ADF or OZ or Airflow or some other tools like that. Now, when as soon as they get any issues or pipeline failures, right, they will be tasked with debugging those. That would be like the next logical step for them. Now, while doing so, first they will be trained, or they will be trained parallelly while they do this particular activity within the team, and they will learn about few terminologies that and the tools that are used in the project, like be it the orchestration tool, be it the data movement, like where the data is originating from and where it is getting ended up, and few other business related terminologies there. So this is a good start, considering that they may or may not have a lot of knowledge on data processes in general, or the specific specific terminology that is related to that particular part of the business, right? So once they are comfortable with monitoring these jobs and pipelines, they will start working on few issue fixes, simple enough, and then they will eventually graduate to solving bigger and more complex problems. So this is like fairly easy start for any beginner's perspective, and this is really important in for them to understand the plethora of issues, or a very wide range of issues that are occurring throughout different pipelines, different systems, and how they are solving them. Now once the once they are comfortable, we can move them to getting the understanding the business requirements and building the pipelines on their own, even solving the data related problems as they progress in their career. This is like a fairly common or a typical journey for any beginner, or who is getting into the field, or who is like fresh out of college, or trying to join a company, and got this like ended up in a data engineering stream. So all of these activities are pretty much like defined as a standard in the industry, like how a person will be introduced to learning about data infrastructure, learning about what all it takes to set up the data infrastructure, build a few things, and maintain them. So this gives a very wide range of experience, according to my own experience so far, and also gives a better overall picture about the data infrastructure systems involved, all the stakeholders that they are serving the data to. If you check about the normal typical data engineering pipeline, right, this would be the pipeline. So basically we will have different systems where we want to ingest the data. As a data engineering team, our first job is to understand these systems, source system, how they are generating the data, and how are we receiving this data. And once that is done, we will be understanding about how to ingest the data into our raw layer, which is the first layer of our data um, uh, warehouse, and then we will start transforming the data once the data is available. And we will also check for any business related transformations that need to be done here. And once the data is ready, once the data sets are created, typically we will use multiple tables or multiple sources, data coming in from multiple sources, and join them, use for our analysis, and create specialized data sets, or data sets that will be used across different departments within the same company in the staging layer. So which is the second part of the pipeline, which also happens in our data warehouse. And once the data is ready, and if any like team or a particular business unit is looking for that particular data, we will be serving them that data through our system, be it a warehouse, be it a specialized database, or be it through APIs, or even for machine learning teams directly giving read access to our data warehouse tables. So this is how a typical data engineering pipeline works. And for a beginner, this understanding this will be of utmost importance. So what are the sources? How are we bringing the data in? And what is the schedule that we are bringing the data in? And are there any stakeholders that are expecting the data within time or within time limit? And how are we going to transform the data and serve the data? So these are the 5 aspects that are really important for any person or any like a beginner who wants to understand this. Now let's understand a few more critical aspects here. Like when we do start as with a fresh perspective, right? We kind of get caught up with lot of tools, business specific or company specific terminologies, and kind of chase upon like what is the latest and greatest tool that is available for the job. It might be good, it might end up being a right choice for some scenarios, but it might not be true for all cases and scenarios. Let me explain on that a bit. So when we do learn about what's going on in the project, how are we monitoring the processes, how are we whether we are doing our job properly through monitoring tools, all of that, we kind of lose emphasis on the overall big picture of the data engineering field. For one, the data engineering role is a facilitator role, where we will facilitate the teams who are looking for the data and then serve them by employing the data engineering pipelines and processes. The second is like data terminologies and methods that we capture these data and serve them, like creating a data warehouse, data sets, creating historical data sets, and using that data to serve the right stakeholders, security aspects, how are we maintaining our code through Git repository. So all of these processes are very important for any data engineering team or any data engineering projects. So to have the specific without having to without getting caught up too much into company specific or organization specific terminologies, we kind of have to look on our overall big picture. What is our role, how are we serving the data, and how what is the right tool to get the job done. So on that note, we will go into few architectures that I have used, and what are the constraints or systems that are employed here to overcome the end user requirement, any issues that we faced while serving the end user of the data. So this is one of the architectures that we had, so where our data is coming up from SAP database, right? SAP is one of those companies which provides ERP or enterprise resource planning, and they provide a wide variety of tools, be it for databases, be it for enterprise management, like finance teams, sales teams, and accounting team. All of the they provide tools for separate business units, or even for the entire organization combined as different tools for different departments. So SAP is one of the leaders in terms of ERP. And in one of the project where I worked, we had SAP as our primary source of data. So the whenever there is a change, or whenever there is a record added, created, updated, or deleted, or even all the CRUD operations, right, that happens on a database, an event would be fired. So this is one of the common pattern where we see data in data streaming or in CDC. So data streaming basically means every event will be streamed as soon as it happens, right? There is another paradigm called or another way of accessing the data called batch streaming, batch process, which we will discuss a bit later. But yeah, this is one of those pipelines or architectures where the data used to flow as soon as the operations on the database happened. Let's just say a customer got into the system, so the record has been created for them. So as soon as that is done, then the data used to flow into a system called Kafka. Kafka is an event streaming system, so it is not just just an event processor, just get the or a messaging system where it just delivers the data and then forgets about it. Kafka is much more than that. So I'll just explain it in a brief manner. So basically, whenever we have placed an order on Amazon, right? So your order details will pass to different teams at the single in a single instance, right? So basically, as soon as you're done with your when you click order now and complete the process of ordering, paying the amount and then confirm the order, so it will be sent to payments team, invoicing team. It will be also sent to order processing team and other teams that wants to know about this particular action done by you. So basically Kafka comes in the picture, where it will get the data from whatever the source, be it a database, be it an API or any source, and it will pass that information or that message to all the subscribers that are listening to that particular kind of events. Be it in this case the inventory processing team, the order processing team, and finance team and payments team. So all of these. So in this particular case, in this particular project or in this particular architecture, every time there is a record in SAP, we used to get the data into Kafka cluster and then into a Hadoop raw layer, and which was exposed as a Hive table, right? So since this was a big, very huge client in terms of revenue and in terms of operations, they had a separate team who maintained SAP systems. They had a separate team who maintained the IT infrastructure, that concerned our Hadoop cluster, as well as there was a middleware team that maintained the Kafka cluster itself, because it is very much central to their business, right? They don't want the data engineering team to kind of handle all of this complexity, right? They are a very huge company, and then they had a lot of resources in setting up and maintaining the infrastructure. So our job as data engineering team was to receive the data at the raw layer, which is a Hive table, and transform it. If you know about SAP, right? SAP has their own way of storing the data using T codes, op codes. I'm not really 100% sure about SAP, but how we received the data was in SAP. The column names was purely in SAP specific naming convention, right? And the business teams wanted to access this data, and the translation need to happen, and even some analysis had to be done, and get a specified data set out of all the SAP tables that we are ingesting into our raw layer. So we in the transformation layer, we had written all the data into all the transformations into a SQL based transformation logic, and every time we want to run the job, we used to run the transformation logic on top of the raw layer and avail the datasets into our transformation layer. So this is a fairly straightforward process, but the business logic that we used to get is converted is in plain English, and we had to convert that into a SQL code, and based on the business requirements, we had to do it multiple times in order to maintain the data model that is required. So once the transformation is done, we loaded the data sets into a different set of tables within the transform layer, and once the data is loaded, it will used to serve to different teams, be it business teams, be it analyst teams, and other teams who want to access this data through APIs, through databases, specialized in-memory databases, where the processing and serving the data is extremely fast. That was not part of the Hadoop cluster. It was a separate in-memory database called memsql, or now it is renamed to or now it is called as single store database. So where we had loaded once the data is done transforming, we used to load the data into single store database. This is one straightforward approach to the data. So since here there are few interesting things that is going behind the scenes. One, as I've mentioned earlier, the amount of engineers working on different systems were really like amount of teams working on different systems were really um, high. Basically, the Kafka cluster, as I mentioned earlier, is maintained by middleware team, which means that they had a dedicated resource in maintaining that particular part of the infrastructure. If it were a small team in a small company, typically a data engineering team might have to take some part of the responsibility in maintaining the Kafka cluster and in checking the performance and the uh, uh, data availability through the Kafka cluster by themselves. So since we had that luxury of having different teams and having different teams maintain the data infrastructure for us, our part of the job was to only concentrate on transforming the data from the raw layer according to the business spec and serve the data. So there is one more aspect that I want to discuss here. That is, we had a 30-minute SLA. So as soon as the data lands in the raw layer, right, it has to reach the serving layer by within 30 minutes. That was a strict deadline that was set by the business team because they were dependent on the data and they wanted to perform the make sure that the data is available to internal and external stakeholders that they that want access to that particular data. Of course, it's a read-only access for them, but we had to serve the data within that 30 minutes. So we had scheduled a job every 30 minutes, and we had to fine-tune our jobs or fine-tune our SQL queries to run within the 30-minute window. So no job should, no instance of the job should run over 30 minutes at any given day. So these were a few constraints that we had, and um, yeah, this is how our data infrastructure was set up. So there were multiple pipelines, processing different tables. If the data was huge in any particular data, we had to put that in a separate pipeline. That is that doesn't have any other tables to process, or any process that takes more than 30 minutes will be broken down into different steps, and we had to run get the processing time run as much as jobs as in parallel, and get the data into the serving layer as soon as possible. This was one of the uh, most simplest of the architecture in terms of architectures, because we didn't have to maintain any source systems or concern about source systems. All we had to do was raise any issues if the data was not appearing in the uh, uh, source systems, and then wait until the problem is solved. So yeah, this is one architecture we had in one. So if we check about if we let's take a minute here to discuss about Hadoop ecosystem, right? So Hadoop ecosystem came around in 2008, as we discussed in our last around 2008, right? So as we discussed in our last one. So they had a lot of tools. The popular one among them is Spark here. Kafka is an event or stream processing platform. Impala is a MPP system, or a massive parallel processing system, where it was an alternative to, or can be used as an alternative to our Spark, where it we used to write SQL queries in Impala and run on our Hive tables and get the output from our raw layer to um, transformation layer, right? So instead of the Impala, we could have used Spark. We didn't do so because the architecture was set up, the infrastructure was already bought, and moving over, or any jobs from Impala to Spark would take a lot of training, access, like communication, like managing different teams, of the expectations. So this was like a hassle. So since we knew that we had data, that could be processed under 30 minutes by doing some clever tricks and all of that. So we kind of ended up with using Impala, not the Spark, even though Spark was really popular at that time. And yeah, the storage was again Hadoop file system, or HDFS, that you see here. And we had Uzi, which was our scheduler. So yeah, this was all um, into one single package. So basically, in the Hadoop ecosystem, right, there are multiple managed services that we could use. One was Cloudera, which was one of the more popular distributions of Hadoop ecosystem components in a single package, where we can use the service or licenses, or pay them up for a year or 2 years under a contract, and get those services available in our own cloud environment. So whatever the infrastructure that we had here, none of the internals of the infrastructure, like where it is deployed or where it is running, were not exposed to our data engineering teams, because as I've earlier told, there was a dedicated infrastructure team there. Now coming back to the our original discussion. So I'll just go through the HDFS or Hadoop architecture for a minute. And if you have any doubts or questions, please let me know on the chat. I'll be looking at the chat for a minute. Okay. Okay. Yeah. Now coming to the Hadoop architecture, right? So basically, in Hadoop architecture, there is a name node or a master node, and we have data nodes where the data is stored locally on them using block storage. Basically, a file will be by sliced into chunks of 128 MB, or how the cluster is set up. The default is 128 MB, and we will store the block in each node without repeating the block in the same node, and maintain read replicas. So whenever we run any queries in um, um, excuse, in Spark, in Impala, or any other querying engine, and the data will be calculated, processed locally on the nodes, and then loaded into the in a different location, be it for a transform layer or be it for any other serving layer. So this is how, in in a brief explanation of how Hadoop architecture works. So Spark runs on Hadoop, even Impala works on Hadoop architecture. So basically, even any Spark cluster that you see, be it on Databricks or be it on AWS EMR, or be it on any managed service that is available across the cloud service providers, every Spark cluster provides follows this architecture pattern. About um, two different distinct examples. So that's why I've put up these two examples here. So the current one that you are seeing is more of a mostly of a cloud based managed service environments. What is cloud based? So all the tools are available on cloud. You just have to select which service you want, and then within 10 minutes your service will be deployed, and you will start working on that. So this is cloud based. And what is managed? So you don't have to manage the servers or their health or the infrastructure or any kind of that. All you have to do is taking care of your own a business logic and your own processes. That's it. So this is what cloud based and managed means. So this is not just this is not just only for data engineering related services. Cloud is basically very much versatile in software engineering, DevOps, and other fields, as we have discussed earlier, right? Now, coming back to this project, right? So we discussed here. So we have different sources, as we have mentioned in this diagram, right? So same in the same manner, we have an Azure SQL database here. We have SFTP or file servers where we receive files periodically, and we have Salesforce instance or Salesforce CRM, and we have also have APIs as our sources. So all of these sources will generate data periodically, and we have to import the data into our data warehouse or into our blob storage layer. So in a Hadoop cluster, what really happens is you will use your data nodes to store the data for raw layer, your transform layer, and even the serving layer for most of the times. But in cloud-based storage, right, the storage architecture changes. It is like pretty much different from what you see in a Hadoop architecture. The storage architecture here is a blob storage, or you can store a single file in one piece, and you can just store as much data as possible. But in case of Hadoop, you'll have to either automatically increase the storage size by yourself, or set a rule to increase that, and maintain the cluster health, and monitor the cluster health by yourself. But in terms of like any cloud-based storage, be it AWS S3, be it Azure Blob Storage or Google File System, you don't have to necessarily go and maintain anything. All is taken care by the cloud service provider, and even they provide certain guarantee that your data will not be corrupted and it will be secure, and based on the configuration that you do, it will be more secure than you yourself maintaining the security and all of that. So this is the guarantee of the cloud. So what we do in a typical data engineering project, right? So we will have different sources like SQL database. We have file servers. We have Salesforce, CRM systems, and APIs, right? So there is a tool or a managed service called Data Factory that is available in Azure. So this is a data integration tool. Basically, it can orchestrate data pipelines. It can transform the data, and much more. But majority of the times in data engineering projects, Data Factory will be used in orchestrating the data pipelines, meaning to get the data from all the sources like SQL, SFTP, Salesforce, APIs, and other different sources, to get the data from these sources and dump it into a raw layer or a blob storage, right? This is where the ADF or excuse Data Factory is used widely. And the merit of Data Factory is that it integrates so well with the Azure ecosystem of tools that you don't the first thing is it's serverless. That means you don't have to worry about how many servers you have to provision through the load, and whether how to set up the infrastructure for them. Nothing is taken care by you. Everything is taken care by the Azure ADF team. So you don't have to worry about anything, and you will also get standardized connectors for all of the sources that you see, and even more than that. The Azure Data Factory is very easy in terms of like setting up the data pipelines fairly easily. You can also do it on your own by using something called Airflow, which is one of the more popular tools in across different clouds in for setting up the data pipelines, right? So Azure Data Factory is like locked into Microsoft Azure Cloud, but Airflow can be used, can be deployed and used in any of the available popular clouds. And Airflow is really popular in terms of mindshare. That means a lot of companies use Airflow, and they have production instances of running the Airflow in production for data, setting up the data pipelines, ML pipelines, and so on and so forth, right? So in one of the projects that I worked, we used a data factory, right? And um, as I've told, data factory we use for building pipelines and getting the data. So basically we end up dumping the data from all of these sources into raw layer based on however the frequency we need to set. We had hourly jobs, we have API, webhooks on the API. Whenever there is a data, it we used to call an Azure function app, and then dump the data in storage location or in Azure Blob Storage. That is basically a raw layer. So once that is done, we had something called transformation layer that is predominantly done by Databricks using Spark. So Databricks is again a managed service. You don't have to maintain any Spark clusters or worry about how how do you provision these Spark clusters, all of that. All is taken care of by Data Factory, and all you have to do is start working on your logic. You can write SQL queries, you can write Spark based transformations in Python, Scala, R, and you can even perform complex analysis queries and on very large scale data sets in Databricks. So this is our transformation layer where we use Databricks to transform the data that is coming up from different sources, right? And all of these, again, the transformation, the ingestion, transformation, all of this will be taken care within the data factory in Azure, right? Next up is, once we do have the transformed data, we will have the data in the Delta layer or in Delta format. Delta is one of the most optimized data file formats, which uses transactional which applies transaction on top of the Parquet files, right? Basically, if a customer updates any information or bunch of customers updated information that day, we can update the Parquet files underlying within the Delta tables and show only and the latest data will be shown. Or you can even maintain the history of that particular customer within that file. So if there is some issue with the data, and if you feel that the some version maybe yesterday or day before yesterday or within certain period of time is the last version of the data that is good in terms of all the our understanding, then we can roll back to that particular version and get that particular data. So this is how Delta works. So once we do have the data in Delta format and in the transform layer, what we will do is, there are few processes that will update the source systems called using something called as reverse ETL. Basically, whenever we are doing the ingestion process, it is called as ETR or ELT. So extract, load and transform, or extract, transform and load. Basically, we are extracting the data from sources, transforming the data, and then loading the data into our Delta tables, right? And transform tables. So once we do transform the data and calculate some specialized data sets, if you want the data back into our CRM systems or in our any operational systems, right, we can insert the data back. This process is called as reverse ETL, and it is very much in practice in many of the data projects in industry at the moment. I've been part of these projects as well, right? So what do we do in ETL? Let me give you an example. So a customer purchases from an e-commerce website, right? They will run some analysis on that particular different customers in within that for those customers who spend good amount of money on their platform and who want better offers based on their purchase history and based on their amount spent. What we can do is, in the transform layer, we can easily calculate or do all of these large scale analysis for all the customers that are on the platform that are active in maybe in the last year and so on, so whatever the business case might be. And we can use that data, calculated data, and populate as a field in our CRM system. Whenever that particular customer calls, or whenever that particular customer comes to our website or to our system, we can propose a better products for them, or higher value products for them to serve them better. So this is one of the use cases that we could do. And even like traditional use cases, like serving the data to internal and external stakeholders, and for machine learning, or in-depth analysis, or even dashboarding. So all of this will be done. So these are the like two data architectures that are common. These follow batch, and this particular pipeline follows batch loading. So what is batch loading here? So batch loading basically means like either you run your job every hour, every 30 minutes, every like every day. So basically you will process all the records for that day or for that hour at once, and load the data into raw layer, and transform the data, and then move the data to serving layer at once. So this is how batch pipeline works. But streaming, on the other hand, continuously sends the data into our pipeline, and we have to be careful in terms of how the infrastructure is set up, and how are we going to process the data. So basically batch is really popular at this point in time, and we it is very easy to set up for batch processing, and we can have as much many pipelines for processing the data in terms of batches. So streaming is somewhat little complicated in terms of setup, maintenance, and assuring the infrastructure never, or the yeah, basically the infrastructure never fails, and we are getting the data. We'll have to monitor those pipelines 24/7, because the data is streaming, and if our infrastructure fails in at some point, we'll have to restart, and get the process up and running. So batch is good. Even if the data is a little bit late, we can run for that hour or for that day, and then send the data. Yeah, I think I'm done with my um, session for the day in terms of explaining what's all uh, I've planned for this one. Let me know if you have any questions or any feedback for this session. We will I'll try to improve, and I'll try to like come up with something new. Also, if you have any topic in mind based on the things that we have discussed, please feel free to chat, leave that in the chat or comments in the on this video, and we can discuss in the upcoming sessions. Okay, hopefully you all had a great time, and see you on the next one. I'll let everyone know through social media, when like Twitter, LinkedIn, and yeah, please feel free to follow and ask any questions if you have any within the topics that we have discussed so far, or any doubts in general for data engineering, and so on. And see you in the next stream. Hope you all had a great time. Bye bye.